Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see problems on superposition theorem. In previous video, I have explained what is superposition theorem, what are the procedures to solve superposition theorem, and we have seen a problem step-by-step solution in previous video, right? So I would recommend you people to go and watch the previous video where you have step-by-step solution, right? So that you can understand the basics about superposition theorem and come back to this video so that you can clearly understand, right? So with this, we will start this particular video. Right. I'll once again revise the procedures of superposition theorem. According to superposition theorem, the very first step you have to do is you have to select one particular source from the multiple sources given in the question. And if you take one particular source, you have to remove all other sources. Right? That is, you have to kill all other sources. How should you kill the all other sources? You have to short circuit the voltage source and you have to open circuit the current source. And after doing that, you have to simplify that particular circuit using mesh analysis or normal uh, series parallel connection. And then you need to find out the current across the element which we need to find out. And you have to follow the same steps again and again for different sources, right? Say for example, if the question is given with three different sources, you have to follow the same procedure for three different sources, right? And if it is four sources given, you have to follow the same procedure for all the forces, right? And at last you need to add all those currents, right? Provided while adding all those current, you need to find out the direction of the current so that whether you have to add or you have to subtract that particular current, you will understand, right? So with this, we will start one particular problem. And here I'm just going to explain how to solve the problem. I'll just explain step by step. But in previous video, I have solved the problem by myself, right? Step by step. So please go and watch that video first, right? So now the given question is find the power consumed by 2 ohm resistor, right? So what is the very first step I said? You have to calculate first, you need to find out how many sources they have given, right? So you can see here the sources is you have three sources, two voltage source and one current source, right? And for that you have to understand first thing, what are the currents that you're going to add and what are the currents you're going to subtract. While solving the problem itself, you are very clear with this, then you will not have any confusion at the end, right? So if you see this particular voltage source, the current flows in this direction, right? So it is from minus to plus, so it will be flowing in this particular direction. So here it is 2 ohm resistor. This is the resistor. So according to this resistor, first voltage source, right? The currents will flow in this direction, right? This direction, right? It flows across this direction, correct? Whereas if you take this current source, the current flows like this. Current flows like this. So for current source again, the direction of current is this side. And similarly for this voltage source, it is minus to plus. So even here the current flows in this direction, right? So it will be this direction. So which means at last you have to add these two currents and then you have to subtract this particular current, right? So this is the very first understanding you should get whenever you see the superposition theorem, right? Now we will solve the problem. Now first step, what you have to do, you have to consider only this particular voltage source. So if you consider this voltage source, you have to remove this particular current source, right? So and then you have to short circuit this particular voltage source, which means you will get a circuit like this, 20 ohm. Just for an example I'm drawing, and you have 2 ohm resistor, and this resistor is 3 ohm, but we are open circuiting this, right? So it is open circuited, right? And then you'll have 5 ohm here. Then you have 5 ohm. We are short circuited here. Understand here it is open circuit, so this resistor will become of no use. 3 ohm resistor, right? 10 ohm resistor, 2 ohm resistor. and 20 ohm resistor. We need to find out the current across this particular circuit. So now what you have to do, you have to simplify this circuit and you need to find out the current across this particular resistor, right? And then you have to take only this current source. If you take only this current source, you need to find out the current across this particular resistor. Similarly, if you want to consider only this voltage source, you have to remove this current source again, short circuit this voltage source, and approach the circuit from this side and find out the current flowing across 2 ohm. And at last, you have to add all these currents, correct? Where this one will be the difference, that is subtract, right? So now we'll see how we have solved it. So you can see this is this question given. Find out the power consumed by 2 ohm resistor, right? So if it is 2 ohm resistor, first thing what I am doing is I am short circuiting this voltage source, correct? Short circuiting this voltage source and open circuiting this particular current source. If I open circuit this current source, then this resistor becomes no value. That is why it is not drawn here, right? So it is 10 ohm, 2 ohm, 20 ohm and 5 ohm, right? Now what happens here? We need to solve. So you can see here to solve current flows in this direction. So here also it flows this direction. So this will be series, right? So this will be series. So how will I simplify? This will be 20 and this will be 5 plus 2 7, right? And again this 5, this 7 and this 20 ohm will be parallel. So that is a parallel connection. So it will be 2 into 7, sorry, 20 into 7 divided by 20 plus 7. And if you got, you will get 5.18. And again now this becomes the series, right? Now we need to find out the total current. What is total current? V 20 divided by this 10 plus 5.18. It will give you 1.32. It will give you 1.32. This is the overall current. This is the overall current. But what we need to find out? We need to find out the current across this particular resistor, right? Across this particular resistor, that is this resistor. So if it is this resistor, right, that is this 2 and 5 has become 7. So the opposite resistor will be 20, correct? So according to current division rule, it is 1.32 into 20 divided by 27. We will get the current as 0.98 and you can see the direction. The direction is this side, right? So we get 0.98 and now we have to take this particular current source alone, right? If you take the current source, we will see the voltage source first. So you have taken this voltage source alone. So if you take voltage source now, what you'll have, again you have short circuiting this, open circuiting this particular current source and you will short circuiting this voltage source, correct? So and if you do that, you will obtain the circuit like this, correct? And if you obtain the circuit like this, you can consider this is mesh 1 and mesh 2. Mesh 1 and mesh 2. And we need to find out the current only across this particular resistor, that is I2. Right? I have already explained how to find out this particular matrix method. Right? Just go through the mesh analysis videos which I have posted already so that you can understand the basics of it. So it is R11, R12, R21 and R22. Right? So that R11 is nothing but the total resistance in this particular mesh, which is 10 plus 20, 30. And this is common resistor, right? This is 20, right? Uh, and again, this will be minus, right? And similarly, this will be minus because it is off diagonal elements, right? And similarly, this is total resistance across this particular mesh, 20 plus 2 plus 5, which is 27. And from this we can able to find out the current, I2 current. What is I2 current? I2 current is 2.992, which is in this direction across this particular 2 ohm resistor, right? And similarly, now we are going to take only this current source, whereas the current source also flows in this direction, 2 ohm, right? And again, you have to simplify that. How will you simplify it? So you can see here, this will become parallel. These two becomes parallel, right? And if you simplify that, you'll get 6.67, right? And this will become series where you can see this becomes 8.67. And now we need to find out the current across this particular resistor. So it will be the opposite resistor. What is the opposite resistor? This one, 5M, right? So the total current divided by the total resistance, right? 4 into 5, right? Similarly, 13.67. 4 is nothing but your current, right? And opposite resistor is 5, total current. Now the current across this 2 ohm resistor for this current source is 1.46 ampere, right? So it is the same steps, and right now we have found out the current across all three sources, right? So now we know that for the first voltage source, the direction of current is this side, and for this current source, it will be towards the particular resistor, right? And also the voltage source, it is towards the resistor, right? So now these two values, right? These two are voltage sources and this is current sources, correct? Right, that is what we have obtained, right? This is the current source, right? And this is voltage source and this is current source, right? So these voltage source and current source is having the same direction, whereas this is opposite direction. So we have to add these two things and we have to subtract this particular value so that we can obtain 3.4 ohm. We will cross verify that. So it will be 2.92 plus 1.46. It is 4.38. So it's 4.38 minus 0.98. It is 3.4. Right? So this is how you have to solve superposition theorem. As I said before, we have to take one source at a time and you have to solve the particular circuit. Similarly, all the sources we have to find out the current value and then we have to find out the total current value. Right? So now we'll see another problem. Now the another problem, you can see you find the current flowing across 50 ohm resistor. Right? Across this 50 ohm resistor for the circuit shown below using superposition theorem. So first you have to find out, you can see here there is three voltage sources. It is the same steps we are going to follow, right? So if it is this voltage source, the current, we need to find out the current across this particular resistor, right? So for this voltage source, the current will be flowing in this direction, right? Downwards, right? So for V1 it is downwards. And for V2 you can see here it is from minus to plus, so it will be upward direction, right? So for V2 the current will flow upward direction, right? And for this V3 you can see it will flow again this direction, right? Minus to plus it will be direct direction, so V3 it will be this direction. So the current from these two voltage sources we have to add and we have to subtract this particular current, right? So same steps we are going to follow. So first we are going to consider this 100 volt, right? So you can see we are taking 100 volt and we are short circuiting all the voltage sources, and I am using the same matrix method. You know how to solve the matrix method. If you have problem in understanding the matrix method, please go and watch the mesh analysis problem video where I have solved mesh analysis using matrix method, right? So for this particular circuit, we need to find out the current across this particular resistor, right? So for here, if you take this particular resistor, there is two currents flowing, which is I1 and as well as I2, correct? So now I1 and I2, we have found out what is I1 and what is I2, and here it is I1 minus I2, correct? So the current across this 50 ohm resistor, we will find it out for this particular voltage sources. After subtracting I1 and I2, we obtain 0.29 ampere, right? Similarly, you take the second voltage source here. Now the second voltage source, once again we consider only this voltage source. All other sources we have to short circuit, right? Remember, this particular source, the direction goes upwards, right? So now you see the same steps we have to follow, right? Matrix method, we found out I1 and as well as I2, and then we found out I1 minus I2 because it is the common resistor between I1 and I2. So after subtracting, we'll obtain minus 0.256 ampere, right? So this is the value which we obtain for this particular voltage source. You can have the same value minus, or if you want to cancel it, you can have it as 0.256, right? And then you have to find out the same current for the third voltage source, whereas we consider only 50 ohm here, right? Now, if you consider 50 ohm, right, you have to follow the same step, same matrix method, right? and we need to find out I1 and I2. If you see here the same again, it is this particular resistor. So we need to find out I1 and I2, right? And subtract that I1 and I2, we obtain I50 for the third voltage source. Now remember what I said before, right? So if you take these three voltage source, you can see voltage source 1, it's going downwards, and voltage source 3 is downwards, whereas voltage source 2, it goes upwards. So these two currents must be added, whereas this has to be subtracted, correct? So you can see here, right? So that is what we are doing, right? We are going to add these two values and we're going to subtract this value, right? You can consider subtraction, or you can just use the same value which you obtained, minus 0.256, so that you can just substitute that minus 0.256 and you can obtain this particular value, right? So you can see here, we will cross verify this, right? So it's 0.29, 0.29 plus 0.499 minus, sorry, this 0.29 plus 0.499, right, minus 0.256. So it will be 0.533 amp, right? So it is the same steps. So if the circuit becomes complicated, you have to use mesh analysis. If it is simple circuit, you can solve it by using series and parallel resistor connection itself, right? So simplification of circuit is very important, but you have to take one particular source at a time and you have to simplify that particular circuit and find out the current across that particular element, right? So today what we have seen is we have seen problems on superposition theorem. We have seen two different problems. I believe this video will be very useful for you. Thank you, my dear students.